Hello students, we have finished all the concepts and theories of the chapter, and again it's time now to sit down and solve some problems. But again, before we start, remember you have to revise all the concepts well before you start off on the problems part. So what you see here is a small summary of the important concepts we discussed in the chapter. So make sure you're familiar with all of them before you proceed to solving the questions. So demand and the demand function, the law of demand, the demand schedule and the demand curve. The linear demand curve function denoted as D is equal to A minus BP is also very important. The exceptions to law of demand also we had studied, like Giffen goods and Veblen goods. The type of goods we had studied, normal, inferior, etc. The determinants of demand we had studied. We had seen how the demand curve shifts up and down. We had seen the related goods concept of substitutes and complements. We had seen the price elasticity of demand, that ED or elasticity of demand is equal to percentage change in quantity demanded by percentage change in price, which is delta Q by delta P into P by Q. The geometric method also we had studied, which is nothing but lower segment of the demand curve by the upper segment of the demand curve to identify the elasticity at any given point in the demand curve. We had seen the relation between total expenditure and elasticity of demand, and we had seen the degrees of price elasticity moving from infinity to zero, where perfectly elastic is infinity and perfectly inelastic is zero. We had seen the degrees of price elasticity moving from infinity to zero. We had seen about perfectly inelastic and perfectly elastic curves. We had seen about the concept of cross price elasticity and income elasticity of demand. So all these concepts have to be kept in mind, and now let's try to apply some of them to some of the problems in the NCERT textbook. Again, we'll be primarily looking only at the numericals. Let's look at the first question in this chapter. Suppose there are two consumers in the market for a good, and the demand functions are as follows. D1P, demand function of the first consumer, is 20 minus P for any price less than or equal to 15, and 0 for at any price greater than 15, which means he will purchase only if the price is less than 15. For the second person, it is D2P is equal to 30 minus 2P for any price less than or equal to 15, and D1P equal to 0 at any price greater than 15. So again, at any price less than or equal to 15, he'll purchase, but the moment price goes above 15, he won't purchase. We have to find out the market demand function. So market demand concept is very simple. We just add up the individual demands. So market demand would be equal to D1P plus D2P, which is equal to 20 minus P plus 30 minus 2P, which is 50 minus 3P. Now this 50 minus 3P is your market demand, but only if price is less than or equal to 15. The moment the market price goes above 15, what happens? The first consumer stops buying. So D1P is equal to 0. And second consumer also stops buying. So D2P is also equal to 0. So market demand is 0 plus 0 is equal to 0. So if price is more than 15, market demand is 0. If price is less than or equal to 15, market demand is given by 50 minus 3P. So that is the answer to this question. Next question is also very similar. Suppose there are 20 consumers for a good and they have identical demand functions. DP equals 10 minus 3P for any price less than or equal to 10 by 3. The moment price goes above 10 by 3, all of them stop purchasing, so demand becomes equal to 0. What is the market demand function? So market demand is nothing but addition of all these guys together. So we can just say 20 into DP, which is 20 into 10 minus 3P, which gives us 200 minus 60P as a market demand function, but only if price is less than or equal to 10 by 3. The moment the price becomes above 10 by 3, DP becomes 0 because everyone stops purchasing and the total market demand is also 0. Because 20 into 0 is equal to 0. So that's the answer to this question. Next question is also a similar question. Consider a market with two consumers and suppose the demands for the goods are as given. This is a demand schedule is given here. You can see price is given, demand for consumer 1 is given, demand for consumer 2 is given for each of the prices. We have to find the market demand schedule. So how do we do this? Let's add one more column here. Market demand is equal to D1 plus D2, which is going to add them together. So at price 1, just 9 plus 24 gives us 33. Price 2, 28, 25, 22, 19, 16. Like that, we can complete the entire schedule. So this becomes the market demand schedule at each of the prices for this particular market with two consumers. Very straightforward, just addition. All you have to remember is market demand is a summation of individual demands. Next question is about the concept of elasticity. Consider the demand for a good. At price rupees 4, demand for the good is 25. Suppose the price of good increases to rupees 5. As a result, the demand for the good falls to 20 units. Calculate the price elasticity. So we have delta P, which is 5 minus 4. It became 5 from 4. So delta P is 1. Delta Q is 20 minus 25 is minus 5. And the formula for elasticity is minus delta Q by delta P into P by Q, which gives us 5 by 1 into 4 by 25, which is 0.8. So the elasticity is 0.8 in this instance. Next is also a simple question about elasticity. Consider the demand curve dP equals 10 minus 3p. What is the elasticity at price equal to 5 by 3? So dP equals 10 minus 3p, p equal to 5 by 3. Now another formula for elasticity of demand is minus bp by a minus bp. This formula is what we are going to use now because it's a lot easier in this question. So substituting from the earlier formulas 10 minus 3p, which is equivalent to a minus bp, as you can see here, we will get ED is equal to 3, which is B, into 5 by 3, which is P, divided by 10, which is A, minus 3 into 5 by 3, which gives us 5 by 5, which means we get an elasticity of demand of minus 1. The next question is that suppose the price elasticity of demand for a good is minus 0.2. If there is a 5% increase in the price of the good, by what percentage will the demand for the good go down? Now, here we are going to use the other formula for elasticity of demand, which is ED is equal to percentage change in quantity demanded by percentage change in price. So very simply, we can substitute in ED becomes equal to minus 0.2 is equal to percentage change in quantity demanded by 5. So solving for this, we get percentage change in quantity demanded is equal to minus 1%. Which is actually an indication of a decrease. So when the price of the good increased by 5%, the percentage change in demand for the good was it decreased by 1% in this case because the elasticity of demand was minus 0.2, which is a ratio of 1:5 if you notice. The next question is not so much a numerical, even though it looks like a numerical. Suppose the price elasticity of demand for a good is minus 0.2. What does it tell us? Minus 0.2, very close to 0, so highly inelastic good. How will the expenditure on the good be affected if there's a 10% increase in the price of the good? So we know total expenditure is equal to P into Q. Okay, the price of the good is increasing by 10%, right? Now it's highly inelastic. So quantity will not change much. Quantity will not come down much. So it will come down only little. So if price is increasing by 10% and quantity is coming down only a little bit, we can assume that total expenditure will increase by a good percentage, which is close to the 10% mark. So the total expenditure of the good will be increasing. The next question is also similar. So what does the question tell us? There's a 4% decrease in the price of a good. So we know T is equal to P into Q. Price decreases by 4%. However, T increases by 2%. Now this is only possible if Q increased by more than the price increase. So Q increases so much only when demand is elastic. Now P came down by 4% but T went up by 2%. Right? Now this would mean that Q has increased a lot. So we can say ED would actually be greater than 1. It has to be more than unit elastic because it's actually pushing up the TE. So that is all the problems from this chapter. So again, make sure that you understand the concepts well and you attempt the problems by yourself as well. Thank you.